Hello, I am doing activity 3.2 in the Geometry Unit 6 book. You might be doing this on Desmos or following along with me in your book. This is on page 24. Congruent, similar, or neither. Match each image to its rule. Then for each rule, decide whether it takes the original figure to a congruent figure, a similar, or neither. Now let's just talk about this real quick. In order for it to stay congruent, it has to be a rigid transformation. So it has to be a rotation, a reflection, or a translation. To be similar, it's got to be a dilation. And neither would be either something not a rotation, reflection, translation, or a dilation. So let's take a look. So, and here, I don't know, you might just go to the choices and then start trying to figure it out, or you might pick a point and kind of see what happened. This one, I'm going to wait on this one. This one, it looks like this point, I can tell this point corresponds to that. So this is the original. So it was -2, 1, and that became 4, 1. Well, it looks like the y didn't change, and the x got multiplied by what? -2? I could try one more. Look at this one. It's the point -1, 1, and that became the point 2, 1. The y did not change, and it looks like I multiplied that by -2. -1 times -2 is 2. Is there anything like that down there? Looks like number 3. The y did not change, but I multiplied the x by -2. So this is 3. Now, let's decide right now, is that a congruent figure, a similar figure, or neither? Well, they multiplied only one of the coordinates by something. If you're going to multiply for a dilation, you have to multiply both, and that would produce a similar figure. They only multiplied one, so this is neither. And that went to letter B. I guess we could put the letters down here. Okay, let's look at this one. I'm going to do D. So this was the original, so that's the point 6, 4, and that became the point 3, 2. So you might try, like, did they subtract? 6 minus 3 is 3. 4 minus 2, let's try another one, see if it's the same, or maybe they divided. So the original point was 8, 4, and that became 4, 2. So clearly it's not subtracting 3 because that doesn't work, but what's another way I can get 6 to 3? Divide it by 2, divide it by 2, divide it by 2. So it looks like they divided the x and the y by 2. Which one does that match with over here? Right here. It says to take the point, whatever the x is divided by 2, whatever the y is divided by 2. So this one is for letter D. Now, we haven't really talked about dividing, but I mean, dividing is the same as multiplying. Dividing by 2 is the same as multiplying by a half, and I did the same thing to both coordinates. So this is a dilation, which would produce similar figures. All right, let's take a look here. We've got F. This is 2, 3. And now that becomes -2, 0. And I've only got 2 left, so let's look here. Does it look like number 2? Have I flip-flopped these? No, that did not go there. So maybe it's this. It says take away 4 from the x. 2 take away 4 is -2. And take away 3 from the y. 3 take away 3 is 0. Yes, it works. And so let's just test it out. Now that we kind of know, this means shift it left 4, down 3. 1, 2, 3, 4. 1, 2, boom. Yep. 1, 2, 3, 4. 1, 2. Yep. This is this one right here. This is C. That's a translation, right? A translation produces congruent figures. That's a rigid transformation. And now we know the last one. It looks like this rule says to switch the x and y and then make the new y negative. Let's see how that works. So this was the point 1, 2, and it became the point, I don't actually know which point that became actually. Is that one? Oh, it's right here, sorry. It became 2, negative 1. Let's look at that. So they took the points and they, whoops, sorry guys, they took the points and they flip-flopped them. 2 goes here, 1 goes here, and then the 1 in this spot had to change sign, so it became negative. See how it says that? Take x and y, flip them, and then whatever this one was, when you plop it into that position, you have to change the sign. Okay, that looks like some kind of rotation. Remember that little trick I was teaching you? If you take a point and you draw it through the center, and then you draw it to the new corresponding, that angle that's created will show you the degree of rotation. That looks like a 90-degree rotation. So that's a rotation, which is also a rigid transformation, which is going to produce congruent shapes. So rigid transformations, which are your translation, your rotation, and your reflections, those produce congruent. Dilations produce similar figures, and if it's none of those, then it's neither. Okay, and we'll write that in our lesson summary. All right, I'll be back for activity 3 in a minute.